Hello students, in continuation of property of material, today we will discuss surface tension. Before starting the point, first we discuss about the material which is made of either atoms or of molecules. Let us say here we have two molecules of the material. They experience an attractive force between them, which is a local force, and this force is called intermolecular force. This intermolecular force also be divided into two parts. The first one is cohesive force, the other is adhesive force. The cohesive force, the force of attraction between two molecules of the same substances. It means the molecules are same in nature. The molecules are same in nature. They interact with each other, and the force is called cohesive force. The range of cohesive force is 10 to the power minus 9 meter. That is up to the nanometer. And the cohesive force is maximum in case of solid and minimum in case of gases. The other type of intermolecular force is adhesive force. The force of attraction between the molecules of two different substances. Now here we have two different substances. So the molecule will be different. One molecule is shown by a circle, another is shaded one. The force between them is adhesive force. And the property is called adhesion. Just like as if we use a drop of water on a glass surface, the water clings with the glass surface. The water clings with the glass surface because of the force of adhesion. We use different type of adhesives nowadays to cling the two materials together, and they are called adhesives. So the intermolecular forces are of two types, cohesive and adhesive. Now the point comes surface tension. The property of a liquid due to which its free surfaces tries to have a minimum surface area. The surface of the liquid try to make a minimum surface area and behave as if it is a stressed elastic membrane. Stressed elastic membrane, and this property to develop a minimum surface area and stressed elastic membrane is called surface tension. Now here we have a cylinder. In this cylinder we have liquid, and this liquid have a surface, the topmost surface, and suppose in this surface we have a line, imaginary line. We are drawing an imaginary line AB. And this line will have so many molecules. This line will have so many molecules. And the molecules nearby, either of the left side or of the right side, will attract these two. The molecules of the line AB are attracted by the left side molecule as well as the right side molecule. So either side of the line AB, there is a tendency to draw away from each other. So the force is acted in either left side as well as toward the right side. The direction of force is tangential. The direction of force is tangential, and it is also making a right angle with the line AB. This tangential force acting per unit length of the line, whichever either of the side, the liquid surface is at rest. The surface is at rest. The force acting per unit length either toward left or towards right is called surface tension, and it is denoted by T or by sigma. Sometimes it is denoted by T, and in some book you will find it is denoted by sigma as well. So surface tension T or sigma is equal to force acting per unit length, that is force upon length, F by L. L is the length of the imaginary line. So its unit will be Newton per meter in SI system, or in CGS system it is Dian per centimeter. As you all of know, the unit of force in CGS system is Dian and length is centimeter, so it is Dian per centimeter. And the dimensions of the surface tension, as we know, the dimension of force is mLT minus 2 and the dimension of length is L, so it is M1 L0 T minus 2, or simply you may say MT minus 2. Now we will discuss the molecular theory of surface tension, how this comes in. As the maximum distance up to the force of attraction between the two molecules is nearly up to the range of 10 to the power minus 9. So the molecule surrounded by other molecule will make a sphere. Here is the reference molecule, and the other molecule surrounded there of the range of 10 to the power minus 9 will make a sphere. This will make a sphere like this one. This sphere is called sphere of influence. Now let us consider we have liquid inside a beaker here, and the molecules are A, B, C and D. These are reference molecules at different places inside the liquid, near the surface of liquid and on the surface of liquid. First of all, we consider the molecule A. Let us consider this molecule A, which is well inside the liquid. This is well inside the liquid. And here is the surface of influence. It means they are nearby molecules of the range 10 to the power minus 9 meter will attract this reference molecules A all around it. So the net force acting on the molecule A will be nearly zero. It means this molecule A may move freely inside the liquid. The molecule A will move freely inside the liquid because the net force on A is zero. Now let us consider the molecule B, which is little bit below the surface PQ. The surface is PQ and the molecule B is little bit below, and the surface of influence just touch the surface. In this case, the force acting on B will also zero because the molecules of the sphere will attract equally, so the net force on B will be zero. Now if we consider the molecule C, which is, if we say here is the molecule C, this is the surface, and here is the molecule C. This molecule C will make the sphere of influence like this one. The forces on this molecule C will be like this one. As the molecule above the surface will not attract there, because in absence of molecules here, there will be no force of influence. So what will happen? The net force Fc is not zero. It is not zero. It is nearly the downward force. The net force Fc will be downward. So the C experience a net downward force. Now if we consider about the molecule D, which is on the surface, so the net force will be either tangential or downward. The force acting on this molecule is either tangential or downward. So net force on D will also not zero, and it is also downward force. And this is maximum downward force. Force Fd will be maximum force. It is more than Fc. And there is no force on B, there is no force on A. So Fd is quite large than Fc. So all the molecule lying on the surface just like as D Here is D, D1, D2, D3. On the surface of the liquid, D1, D2, D3, D4 and so on. The net force is maximum on the surface and it is downward. So the layer PQ will experience a force, downward force. So it will make a thin film, that is PQRS. And therefore the free surface of liquid behave like a stressed membrane. And thus that is the molecular theory of surface tension. Now, what are the applications of the surface tension? If we think we have a brush and we dip this brush inside the water. We have a brush and these are the threads of the brush, and if we dip this one inside the liquid, and now if we take them out, what will happen? We will see the brushes clings together like this one. So the hair of the shaving brush or simple art brush will cling together when they are taken out from the water or from the color. Now if we take a soap solution, if we have a soap solution here, and if we take a thread like this one and make a loop, this is cotton thread, and if we dip this thread on this soap solution, we will see the thread will make a circular shape, because the surface tension the adhesive force will attract the molecules of the thread with the molecule of the liquid soap, and because of this surface tension the loop will be stressed. Or if we take a simple ring on this soap solution, and if we take this metal ring from the soap solution, the soap solution will comes on the metal loop, and this will be a soap membrane. If we take a greased iron needle, a simple needle, and if we greased them and take them on the surface of liquid, when we place it gently on the surface, the needle will be on the surface. It will not sink. The needle will not sink. Why this needle will not sink? Because of the surface tension. Here there will be a surface tension applied like this one. And the membrane will be developed and the needle will not sink because the weight will be equalized by the surface tension. because of the adhesive forces, molecules of the needle and the molecules of the liquid. Same way, when mercury is split on the surface, the mercury will comes in the form of globules, the small droplet type. The tiny globules are spherical because of the surface tension, and as they are very tiny, so the gravity is negligible. If you take a bigger globules of the mercury, it will be an oval shape. It will be flattened on the surface. The round shape on the edge is because of the surface tension. The umbrella, raincoat, tents and canvas have tiny holes in them, isn't it? The umbrella will have tiny holes, raincoat will also have, tents, canvas will have tiny holes. When rain falls on them, the water does not passes through the pores. The water does not passes through the pores. Because of the center surface tension of water, it prevents from passing through the fabric unless the inside is touched. You will feel the wetness, but the water will not come inside. As oil has lesser surface tension than water, so drop of oil float on the surface of water, as the surface tension of water is more than the oil. The oil is stretched in all the direction as a thin film. This property is used to prevent the mosquito breeding. We may split the oil on the surface of water so mosquito will not breed. The other example, the oil and grease spots on the cloth cannot be removed by a pure water, but we use a detergent like soap. When we add in water, the surface tension of water decreases, and when it decreases so much, then the surface tension of oil is more than water. Then oil will not wet the surface of cloth. Thus the oil, grease and dirt particles will mix with the soap solution easily. Hence clothes are washed easily. The antiseptic also have a very low surface tension, low value of surface tension, so that they may spread easily on the surface of a screen. Or a wound. Due to low surface tension, antiseptic also spread properly over the wound. Surface tension of the liquid, lubricating liquids and paint is also kept low. So that they spread over a large area. Lesser the surface tension, spreading is more. A rough sea in old time can be calmed by pouring oil on its surface. In soldering the wires with the PCB, we use a flux on the solder. This reduces the surface tension of the molten tin and it is spread easily. When the molten metal is poured into water from suitable height, if we think here is molten metal and here is the water, the cold water. When the molten material is poured into the liquid or the water in a small quantity, a spherical balls will be developed. A spherical ball will be developed because they have a tendency to make smaller surface area, to make smallest surface area of the same volume, the shape will be sphere. So the ball of metal will be formed. If a small irregular piece of camphor is floated on the surface of pure water, it does not remain steady but dances on the surface. This is because irregular shaped camphor dissolved unequally and decrease surface tension on the water locally because it is uneven surface of camphor, so uneven adhesive forces. So because of the surface tension decreases, the unbalanced force make it to move haphazardly here and there in different direction. So these are some examples of surface tension and applications of surface tensions. So I think you will be familiar with the surface tension phenomena. Thank you.